My dear friends, welcome to SEKAR classes on data structures through C. This is lecture number 84. In this lecture, we will try to understand insertion sort. Best case time complexity of this particular algorithm is big O of n. Average case time complexity big O of n square. Worst case time complexity of big O of n square, where n is number of elements in given list. Anyway, I will discuss these time complexities in detailed manner in a course known as Design and Analysis of Algorithms. I will discuss little bit about this complexity at the end of this lecture. This method used in this particular algorithm is insertion method. This algorithm is table algorithm. I already explained, I think it is lecture number 80, while explaining bubble sort. I discussed what is table algorithm, what is definition of stable algorithm, why an algorithm can be treated as stable or unstable with proper illustrations. I explained in bubble sort algorithm lecture. I request you to go through that lecture once. Basically, this comes under comparisons. This class belongs to, this algorithm belongs to which class means comparison sort. By comparing elements only, we can keep elements in sorted order. Advantage of this particular sorting algorithm is it is simple algorithm. It is suitable for small lists. This is basically in place sorting algorithm. In place sorting algorithm means it requires or it needs less amount of memory. If you speak about its disadvantages, the disadvantage of this insertion sort is it does not perform well as other better sorting algorithms, just like a quick sort, like that. This is not that efficient. There are other sorting techniques which are better than this sorting technique. Even it has got big O of n square complexity. In the case of average case, in worst case, it takes big O of n square, means it's a little bit expensive. This insertion sort is useful only for small set of elements, for few items only. This is applicable for lists which is having few items or few numbers. Now we will try to understand logic behind insertion sort. Insertion sort inserts each element in proper place. How it can insert, I will discuss. Just let me assume there are n elements ARR 0 to ARR. There are n elements ARR 0, ARR 1, comma, so on, ARR n minus 1. 0 to n minus 1 means how many elements are there? N elements. There are n elements. Now, pass 1, ARR 0 is already sorted. Why? Because first element, if you need not bother about first element, whichever element is present, you can assume it is sorted. Now, just compare, that is known as pass 1. In pass 1, ARR 0 is already sorted because of only one element. Now, you must think about ARR 1. ARR 1, ARR 0 is already sorted. Now, what about ARR 1? ARR 1 is inserted before. How many possible positions for ARR 1? There are two possible positions. Either it can be here or it can be here. Therefore, ARR 1, maybe if it is less than ARR of 0, that can be before ARR 0. If it is greater than ARR 0, it can be placed after ARR 0. Therefore, there are two possible positions to place an element. ARR 1 is inserted before or after ARR 0. What does it mean? ARR 0, comma, ARR 1 is already sorted, isn't it? Now, what about ARR 2? How many possibilities are there? Either I can keep here, or keep here. There are three possibilities, isn't it? ARR 2 is inserted before ARR 0, means here. Between ARR 0 and ARR 1 means here. Even after ARR 1. Depending on its number, I can keep in any one of these three possible positions. After keeping this one, first three elements ARR 0, comma, ARR 1, comma, ARR 2 will be in sorted order. Once if I keep all these elements in sorted order, next element will be ARR 3. What are the possible positions for ARR3? It may be here, it may be here, it may be here. This process, it will be continued, isn't it? Same logic you must apply. It must be continued till pass n. ARR n minus 1 is inserted into its proper place in array, so that ARR0, ARR2, so on, all these elements will be sorted. Anyway, I will try to explain this concept with the help of one simple example. Let me consider this elements 82, 42, 82, 42, 49, 8, 92, 25, 59, 52. First 82, this is ARR0. ARR0 is in its proper place, first element. That's what algorithm says. ARR0 is already in its proper place. Now this is ARR1. There are how many possibilities for this particular element? Either I can keep here or I can keep here. As 42 is less than 82, I must insert 42 before 82, isn't it? That's what it says. Now we are inserting this 42. Now these two elements are in sorted order. Now what I have to do? This 49, what are the possible positions? Here or here or here. But as 49 lies in between 42 and 82, I must keep 49 in between. I must insert 49 in between 42 and 82, so that this list will become 42, 49, 82. Therefore these three elements are sorted. Now I must keep 8. This next element possible positions may be here, may be here, may be here, may be here, depending on its value. Depending on its value, I must insert that 8, isn't it? That's what it says. What we did till now, these elements are in sorted manner. Now I must insert 8. Where can I insert 8? I must insert 8 before 42, isn't it? Therefore 8 is inserted. Therefore 8, 42, 49, 82, these are the elements which are inserted. Now what about next element? Next element is 92. What are the possible position? First position, second position, third position, fourth position, fifth position. There are 5 possibilities, isn't it? Therefore as 92 can be inserted only after 82, this is already in its proper place. Therefore all these elements are sorted. Now what about 25? How many possibilities for 25? One place, first place, second place, third place, fourth place, fifth place, sixth place, isn't this? There are 6 possibilities, isn't it? Therefore where can I keep 25? I can keep 25 as it is in between 8 and 42. That 25 can be stored in between 8 and 42. That list become 8, 25, 42, 49, like this. Now what about 59? What are the possible positions? These, after keeping these elements, what are the possible positions for 59? First one, second one, third one, fourth one, fifth one, sixth one, seventh one. Therefore 59 can be inserted here. Therefore as 59 is in between 49 and 82, I must keep 59 in between 49 and 82, isn't it? That's what it says. Now what about 52? What are the possibilities for 52? All these elements are sorted. Now 52, where can I insert? How many possibilities? 1, 2, 3, 4, 5, 6, 7, 8 possibilities. This 52 can be placed in any one of the places, but depending on its value, as it is in between 49 and 59, I must insert 52 in between 49 and 52. Now this is sorted list of elements, isn't it? This is sorted array. This is output, isn't it? This is sorted list of elements. This is sorted array, isn't it? Now in insertion sort, we insert the elements before or after. That's what I discussed. How many comparisons we need? First 1 comparison, then 2 possibilities, then 3 possibilities, n minus 2 comparisons. If there are n elements, 1 comparison, 2 comparison, 3 comparison, so on, n minus 2 comparison. Last, finally, actually, if you observe this one carefully, how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. That means how many elements? 1, 2, 3, 4, 5, 6, 7, 8. 8 means how many comparisons finally we need? 1, 2, 3, 4, 5, 6, 7, 8, isn't it? Therefore, I need number of comparisons, 1 plus 2 plus 3 plus n minus 2, so on, n minus 1, so on, like this. Even if you keep plus n also, it will not make much difference. Why? Because while calculating big O notation, it will not make much difference. I can say it need. I can write this as 1 plus 2 plus 3 plus so on, n plus n minus 2, so on, n minus 1. If you, as it is summation of first n natural n, there is a formula for summation of first n natural numbers, Sn equal to n into n plus 1 by 2, but it is summation of first n minus 1 natural numbers. Therefore, n minus 1 into n minus 1 plus 1 by 2. Therefore, minus 1 plus 1 will get cancelled, n square minus n by 2. Therefore, this must be big O of n square, isn't it? That's what it says. This time complexity is big O of n square. Yes, just go through it once, just understand this numerical example. First understand this numerical example. After understanding example, just I request you to go through this algorithm, then try to understand this time complexity. If you have any difficulty in understanding this analysis of these algorithms, I will record a separate lectures on a subject known as design and analysis of algorithms, where we will discuss in detailed manner about these complexities. At least I am being understand this logic with numbers, so that I will explain program on this particular lecture in lecture number 85. That is in my next lecture. I will explain the program on this particular sorting technique. Thank you very much.